Hello everyone and welcome back to the Nerd Cave. Today we are doing a new version of an old project posted 2 years ago. Transform an old broken keyboard into a macro keyboard. This video has been my most successful video on this channel with a total of 51,000 views, 1.7 thousand watch hours, a crazy 543 subscribers and a total revenue of $45.36. A fun fact about this project, it was done during lockdown, so I only had a limited number of electronics and it was difficult to do a second version. Well, it's now 2 years later and everything has improved quite a lot. Sticking with the original version, in the second version we still have the microcontroller exposed on the side. So what do you think about the electronics being shown, like the microcontroller? I think it looks kinda nerdy and I like the style, but would you prefer a cleaner look if the microcontroller was at the bottom of the PCB and inside the enclosure? Let me know in the comment section. So let's take a closer look at this new macro keyboard. We have 11 programmable keys here, but if we count the rotary encoders, it makes 13 keys in total. The rotary encoders are useful for many different applications, like scrubbing through Premiere Timeline, or adjusting your computer volume and many other applications. The RGB LEDs on the bottom also shows which mode we are in if you do not want to look at the OLED screen, and RGB just makes everything better. The push button on the side is used to switch between different modes, which you can add as many as you want. The LCD screen will display the current mode you are in, and with some more coding, we will be able to display the macro that is executed. If you are interested in that, just let me know in the comment section. I will not take 2 years this time to make an update video. If you want to make your own macro keyboard like this, you will need the following components. The brain of the macro keyboard, the Raspberry Pi Pico. The reason for using the Pico in this project is due to CircuitPython, which gives a human interface device library that allows the Pico to act as an input device. This means that we are able to code any commands and assign it to a key on a macro keyboard. The HID library is very well documented, and we will use this as a reference to create macros, which I will show you later in the video. The next component are these female header pins, which I use to easily connect or remove the Pico from the PCB. The next components are the rotary encoders and cap for the knobs. Next on the list is the OLED display, and we are using the SSD1306 OLED display. The next components are the mechanical keys. I could have desoldered all keys from the broken keyboard, but I found these ones very cheap online. The next component is this push button, which will go in from the side, which will allow us to change the modes. We will use these KF103 connectors on the bottom, which will connect the switch and the RGB LED strip at the bottom, which is the popular WS218B LEDs. The next part on the list is our custom PCB. I have made this in EasyREA. The schematic is very basic, as we just connect each button to a GPIO pin on the Pico. After I was happy with the schematic, I placed all the components on the PCB and ordered it through the one and only JLCPCB. It is very easy to order a PCB online. The PCBs from JLCPCB are very good quality, and recently they allow for colored silkscreen PCBs. JLCPCB has many coupons throughout the year, and you can check the link in the description to sign up to JLCPCB. From EasyREA we can export the DXF file of the PCB, which we can import in Fusion 360, which we can easily design an enclosure. I decided to make a simple enclosure, but you can go crazy and make anything cool. The bottom part will be screwed in place with a 2mm screw to the main enclosure. After designing the case, I sent it to the 3D printer, and after a few hours we had our printed parts. The 3D printer parts came out looking great. There are a few minor defects from the printer, but overall I am happy with the quality. The 3D printed parts and Gerber files is available on my website. Check the link in the description. So all that is left to do is to solder the parts to the PCB. A tip when soldering PCB is to use blue tack to stick the parts to the PCB to keep everything in place. I found this very useful. We will start with the female header pins, rotary encoder and LCD first. The resistors will be soldered from the bottom with the 2 connectors. After all that, we can snap the switches in place and then solder the switches to the PCB. We then glue the button on the side of the case, which will be used to switch between different modes on our macro keyboard. Then we can go add our keycaps to our switches. We then need to add the bottom part of our enclosure, which will hold the LEDs. After making the final few connections, I plugged in the Raspberry Pi Pico and uploaded the code, and everything was working fine. The code for the macro keyboard is very simple, and I have written comments and explained the code in detail on my website. On the website you can download an older version of CircuitPython along with the code. Press and hold the boot cell button and plug the Pico into your computer. Now copy and paste the downloaded CircuitPython on your Pico, which will show as a removable device. After a few seconds, CircuitPython will be installed on your Pico. Now copy and paste all the code, and you will see the code booting up. And just like that, you have a working macro keyboard. I already started with a new version of a macro keyboard, so that will be version 3. In this version we will have a joystick. The joystick will be used to control your mouse, so be sure to subscribe not to miss it. I hope you found this video helpful, and I will see you in the next video.